expressions below are equivalent to 1 over, in parentheses, 2x gets raised to the negative second power. Be sure you indicate all the correct solutions. So one of the things I didn't realize but I like about this problem is the fact that it's nice to have kind of a common place to go when you're simplifying an expression. That way you can compare two different expressions and see if they're equivalent or if they're close to being equivalent to each other. This thing, we've talked about we don't like the negative exponent, so probably a good place to start would be to take this expression and get rid of the negative exponents. So I'm going to carefully rewrite it in this zone right here. So I've got 1 over, and then I've got 2x gets raised to the negative second power. So something is getting raised to the negative second power. And again, the tool that we have for dealing with that is raising the same thing to the positive second power in both the numerator and denominator. So I'm just going to put a 2x to the second below and a 2x to the second above. Now again, our reasoning is, what do we have in the denominator now? We've got 2x to the 0 power, which is just the number 1. So our denominator is 1, and in our numerator we've got 2x times 2x, which is 4 times x squared. So what we are looking for are expressions that are equivalent to 4x squared. And it turns out I thought there were 4 of them initially when I glanced at the problem, but then on careful inspection I realized there's actually only 3 of them. The first and most obvious one that's equivalent to 4x squared, now I should write this 4x squared so we know this is what we're looking for, is A, right? A is 4x squared, which is nice. B, if I'm getting kind of good at this, if I was to simplify this, this would be x squared over 2. Notice that this 2 is not getting raised to the negative second power, it's only the x that's getting raised to the negative second power. C, the square root of 16 is 4, and the square root of x to the 4th is x squared. So this actually is it, 4x squared. And to verify that, if I multiplied that by itself, 4x to the second power, you could see I would get exactly 16x to the 4th power. So yes, the square root of 16x to the 4th is 4x squared. So we have yet another way. So C is also a valid way, or a way that's equivalent. So A and C so far. In D, if I look at that, probably a giant one would be helpful here. In my numerator I might write 4 times 3 times x cubed times x squared. So I'm just breaking it down by kind of looking at the denominator and what I have. I can see I've got a 3, so I was writing it as a 4 times 3, the 12. And I've got an x cubed in my denominator as well. That's why I broke up this x to the 5th. Instead of x to the 5th, I wrote x squared times, or x cubed times x squared, but it's still equivalent to it. Very clearly I can see this 1, and what I'm left with, if you look closely, is 4x squared. So this is also equivalent. The last two are not. F was the one that I thought perhaps was, because the absolute value of negative 2 is just 2, and it turns out when you square something and take the square root, it's just going to be x. So this is actually 2x squared times another 2x squared, which gives me 4x to the 4th power. Awfully close, but no, there's 2 extra factors of x in that one, so F is not equivalent. And then if I look finally at E, I could multiply this by a 2x squared to the positive 1 power, and then my numerator 2x squared to the positive 1 power. Now in my denominator, when I multiply these two, right, this is why I selected those, this ends up being 2x squared to the 0 power, which is 1, and in my numerator I end up with negative 4x squared. So this is very close, right? This is the only thing that differentiated it, the fact that it was a negative 2. So the 3 that were equivalent were A, C, and D. B and E and F were not.